So we are talking about electronegativity. So what is electronegativity again?
The strength or energy
The difference?
atom away from an element.
What was that?
The energy it takes to take an atom away from an element.
You mean an electron from an element, and that's ionization energy.
That's what I meant to say.
Yeah. So electronegativity is the desire to get an electron. So you want to get an electron. So the one who wants to get the electron the most, again, is fluorine. The one who wants to get electrons the least is francium. Opposite poles. So fluorine wants to get it so bad because it's so close to being a noble gas, and it's also very small. So it doesn't have to worry about that it has all of these electrons already. It just has to try to get that one so that it can be just like a noble gas. Where if you notice, if you go down the scale, the electronegativity decreases. So fluorine is the greatest, then chlorine, then bromine, then iodine, then what is that? I think it's Astian. Okay, so so the way that we determine, as we were talking about last time, whether or not you're going to have a polar compound, or if you're going to have a nonpolar, or you're going to have more of an ionic compound. Okay, so we said that if it was the difference between those two bonds, let's say we have carbon and hydrogen that are bonding together. Oh, this is not working out right. I am on the wrong screen. Okay, can you guys see the big screen now?
Yes.
Okay, good. Why didn't any of you guys say anything? You were just gonna let me sit there and have the little teeny screen so you guys can look at?
It was visible. It wasn't that tiny.
I just thought you were trying to punish us for doing so horrible on the test.
That was exactly what I was doing. That was exactly it. So if I have a bond between carbon and hydrogen, so if you look at their numbers, here's hydrogen, here's carbon, right? So we would just take the difference between those two electronegativities. We'd always start with the one that's the biggest. So 2.6 minus 2.2. And this value is going to give us 0.4. So 0.4 is less than 0.5, I think was the one that I gave you, or 0.6. So since it's less than 0.6, that means it's going to be a nonpolar covalent bond. Polar covalent bond is going to be anything that is going to be greater than that 0.6, but less than, I think it's 1.8.
Yes, 1.8.
Okay, so if I have, let's see, oxygen and fluorine. So what am I going to do? Is that going to be polar or non-polar?
Was it polar?
It's going to be polar, right? Because it's at, actually I should put equal here. It's actually right at that 0.6. So that means that fluorine is going to be pulling that electron closer to itself, and oxygen is going to get it less of the time. So they're going to form what we call a dipole. So if these guys were bonding together, meaning that they're sharing this electron, this guy is going to be what we call partially positive, and this guy is going to be partially negative, meaning that the electron is spending more time with the fluorine than it is with the oxygen. How many of you guys are divorced and share kids? Anybody? Nobody? Good. That's great. Glad to hear it. How many of you guys come from divorced parents? And was that kid that was being shared? Nobody. That's
Mine
great.
were.
What was that? You were?
Yeah.
Okay.
Same.
So did your parents have an arrangement where they got you part of the time?
Yeah.
And then the other, was it even or was
No.
it? Okay. So that's like an example of that dipole. So you're like the electron that's being shared. Who got you most of the time, your dad or your mom?
My dad.
Your dad?
Hmm.
Okay. So your dad got to spend more time with you, right, than your mom. And so that's exactly what's happening with this electron. The electron is going to spend more time with, in this case, fluorine is going to be the dad. And then in this case, oxygen is going to be the mom. So spend more time with fluorine. So it's there most of the time, and then just a little bit of time with oxygen.
So why would we know it would be spend more time with fluorine? Is it because of
Because fluorine has a higher electronegativity than oxygen, right? And since it falls within that range, you know, it's 0.6 or greater, right? Then
Yes.
that means it's going to be a polar covalent bond. And anytime you have a polar covalent bond, that means they're sharing unevenly. Okay, do you guys get that? Do you see it?
Yeah.
Okay, good.
Yes.
So I'm just curious, why do you guys think you did so poorly on the exam?
Dumb mistakes. At least for me.
Mistakes? Okay.
Yeah, I forgot to add like the measure, like the not electronegativity one, but the frequency equation one.
Yeah.
How it gave us options as to like between what wavelength or whatever. I forgot to add like the unit of measure for it, so it marked it wrong. So that was like a dumb mistake.
Okay.
I had a lot of problems on like the not the ones like we had to do the like show the work for, but the other ones, I don't know, they were just like I felt like I didn't remember learning about some of that stuff.
Okay.
For me, it's timing. I always try to like go back and make sure I'm doing my work correctly. And when I'm like focusing on the clock running out, then I start to panic. So I just start answering what I can really quick.
Mm-hmm.
That's usually that's what happened at the end. Like I knew I was running out of time. And so I started answering the last questions as quick as I could.
Okay.
I think that was it for me as well too. That added to it. My brain just kind of froze thinking of like how many questions I had to answer and stuff.
Yeah.
Time management, pretty much.
Okay.
I agree. And yeah, time management.
Time management. Okay.
I've been out of college, Dr. Henry, for about 15 years now.
Oh,
And
really?
like the
Yeah.
first test, and I started and I felt like I was okay. And then after the first few questions, my mind was everywhere. Every answer seemed like it was correct.
Mhm.
Or the ones you have to work out, I'd work it out. I got the answer, but then as I looked at the other ones, I thought, well, maybe it's that one. And I think I just have to get back into the flow of things.
Yeah. Okay. And how many of you guys did not do the practice test or only did the practice test one time?
I did the practice test one time.
I think I did it like three or four times. I wish I wouldn't have worked because I would have done it all 8.
Okay.
And I didn't know your tests are pretty much like your practice tests are kind of like almost similar, huh?
Yep.
Yeah. I should have like asked because I did really bad on those. And I was thinking like, well, maybe he's just like making these harder. But I think next time I'm going to ask like, what? I don't get it.
Yeah.
I did the practice test 3 times, and even then, I think my highest score was, I think, 31 out of 40.
Hmm.
So for me, again, it's like I'm new to school again, and I think I know stuff, and then when I'm questioned, I panic, I guess, and then I think everything's right.
Okay.
I took the practice test like 2.5 times, and I say half because I had so much homework that entire week when we had our discussion board and the exam and the practice exam and all of that. So then I had a lot more classes this year than I've ever had. So
Yeah.
I think like my time management was not the best since it was my
Okay.
first year of having so many classes.
Okay.
So I don't think I got to practice as much as I would have liked. So that was like my fault.
Okay. Did you want to chime in, Eric?
Me?
Yeah.
Well, same thing, just time management, and then like I felt like I was getting some right, and then like the practice exam, I was struggling with that one too, honestly, and it's pretty much the time management. I was dealing, it's just my fault, you know. I don't want to, you know, I want to own up to it. I freaking didn't do my part in studying as much as I should have had.
Okay.
I know, I feel that way too. Like we all have an excuse, but
Yeah, that's me. I don't like
I
I
said it
want
before,
to make
we all signed up, so
wanna
we
make
should have
it-
been prepared.
I want to, but not like I gotta own up to it, you know.
The
Okay.
written questions seem to like, they're not very direct sometimes. So sometimes that's also confusing. Like when I don't feel that they're pretty direct, like it confuses me. Like, okay, what am I getting asked? What do I need to solve, or what is it asking for? Because it doesn't look like exactly how it would look on like when we're doing it in class sometimes.
Okay. Or on the homework? Do they look like some of the ones that were on the homework?
Yeah, they do.
Yeah.
Okay.
Is
Okay.
it
I just wanted
weighted?
to know. What was that?
Is it weighted?
Yeah, your grade is weighted. And so
Oh.
your test represents, it's going to be like 36% of your grade. So each, yeah, so it's a hefty weight. So you want to do well on it. I mean, you could blow your test, right? You could get, well, not blow. You could get D's on all your tests. And if you've done all the work that you're supposed to do, you could pass this class, right? Because I find that some of the smartest people, some of the most brilliant people are not necessarily the best test takers. Some of them are the ones that actually have good hands. And when they get into that mode of, you know, start thinking about the labs and
You
stuff
get
like
like
that, they
test
tip.
anxiety.
Exactly.
Yeah, I suck at test testing because I start to overthink like so much freaking like all the answers look good, and I'm just like, damn, like I just start to overthink all the answers and like, damn, I should have put this one, I should have put that one, but then I
Yeah.
just, you know, I'm just gonna go with that one, and then while I'm doing all that, just the time's just running out.
Yeah. Yeah. No, I understand. But the thing is that you're not going to pass with an A or a B if you fail all your exams. And
Ooh, also, sorry, I didn't realize a lot of the lab stuff would be on there too.
Yep.
So now I know I need to like take more notes during lab.
yeah. Yep. So yeah, everything is fair game, you know, on the exam. So what I was saying is that you also, all of you guys, or most of you guys, are going to have to take some type of test. Like if you're going into the nursing, it's the TEAS test. And then you also have to take, for your actual license, you have to take a test, right? So you need to get in the habit of improving your test taking skills. And they're going to be, you think these problems are very vague, wait till you get to those tests. And I've borrowed some of the problems from those tests so that you guys will have some experience with it as well too. So
Yes, Dr. Henry, I just want to add to that. If anybody's doing nursing, they'll give you a question and they're all correct. and you're supposed to pick the more appropriate one according to the situation, according to the individual, according to just different things. But in reality, they're all correct. So it is practice at test taking, and I don't even know if there's a way to prepare for it, though. You just got to take your classes, and each class is different.
Okay, so are you guys feeling comfortable with electronegativity?
I have one question, and I think it's the same one I had asked on Monday.
Okay.
When we're dealing with electronegativity, our elements are trying to bond to the noble gases only, or there's electronegativity where elements are bonding to other elements even though they're not noble gases?
Okay, so they're not trying to bond to noble gases. In most cases, the noble gases will make certain bonds, but it's rare. All the other elements are going to try to sit there, like for instance, your non-metals are going to try to sit there and bond together to try to be like a noble gas. So your goal is, noble gases are stable. Let's see, hold on.
Yeah, if you'll put up that other little table that you had.
Yeah, I'll pull it up in 1 second though, because you got to understand this. These guys are stable, right? So if you're stable, you don't need anybody to bond with, right? So if you have everything in your life is perfect, do you need anyone?
Nope.
No.
Well, these guys here, their lives aren't perfect. They're missing something, and they know they're missing something. And so their goal is to try to get to the point where they're perfect, right? And this, again, all deals with energy level. Noble gases have a very low energy level. They're cool, they're relaxed, it's stable. These guys, they have a higher energy level, so they're trying to bond with somebody else to sit there and help them settle down so they're not using as much energy, right? And so they bond based upon whether or not there's compatibility. So for instance, non-metals and metals, they form ionic bonds. That's lower energy than them by themselves. And so that's the reason why they form those bonds. Non-metals and non-metals form covalent bonds, okay? And metals, they will actually form what they call metallic bonds. Now, these are, again, trying to get to a lower energy level so that they're like the noble gases, okay? So if you take a look at that table, as you were mentioning, you notice that you don't see the noble gases here at all, right? You have the halogens, but none of the noble gases, right? That's because the noble gases don't have any electronegativity because they don't want anything. They're happy the way they are. Fluorine, on the other hand, is very electronegative because it really wants an electron. Francium is very low in electronegativity because it doesn't want an electron. It actually wants to get rid of it. So do you get that?
Yes.
Yeah.
Yes.
Okay, so we have multiple bonds. We could have a single bond, we could have a double bond, or we could have a triple bond. We've already talked about that already when we were doing some of the Lewis dot structures. So you can have more than one atom, or more than two atoms could sit there be bonded. So in this case, we have 3 different atoms bonding together. We have 2 hydrogens and an oxygen. In the case of nitrogen, we have, or ammonia, we have nitrogen and 3 hydrogens. Okay, so again, when you're trying to sit there and bond, you want to try to be like the noble gases. And to be like the noble gases, we're talking about in terms of isoelectronic, like the noble gases, meaning that have the same number of electrons as the noble gases. So you want 8 electrons around you. So you want to be able to obey the octet rule, meaning that you could have 8 electrons bonded to around this oxygen, And we know that hydrogen is going to try to be like helium, and it only could have 2 electrons around it. It will never have more than 2 electrons around it. So hydrogen will never be a center atom. Okay, so if we look around here, look around the oxygen in the middle, the water. How many electrons are here?
8.
How many?
8.
So 2, 4, 6, 8. So since it has 8 around it, it's acting as if it's neon, right? And so it's stable. It's lower in energy, and it's stable in this form. But it's sharing those electrons with hydrogen. Now it's sharing unevenly, but it's still sharing them, okay? So then hydrogen gets the electrons some of the time, and so then its octet is full because it's like helium, right? Which only needs 2 electrons to be stable. So do you guys get that? See it?
They're sharing it.
They're sharing it, exactly. They're sharing it, okay? Piece of cake so far?
Kind of.
Kind of. Okay, so when we talk about, let's say, ammonia, how many valence electrons does nitrogen have?
5.
It has 5 valence electrons. There's 1, there's 2, there's 3, there's 4, and there's 5. Let me do this. Can you guys see my little dots?
Yes.
Yes.
Okay, how many valence electrons does hydrogen have?
1. Wait.
2.
1.
1.
1.
1.
Oh, good. Share 1. Share 1.
Hydrogen has 1 valence electron. How many electrons does hydrogen have, period?
2.
1.
It has
2.
1, right? Who says 2? I'm going to beat you one more time.
I keep saying 2 because I thought
Okay. This is hydrogen. It has 1 proton. How many electrons must it have? Unless it's an ion.
My bad. I was looking at helium, so that's why I said 2.
Okay. So hydrogen has only 1 electron because it needs to balance out that. Okay. So now it wants to be like helium, who has 2, and helium is stable. So what it's going to do, it's going to form bonds. They're going to form a bond between that electron of hydrogen and that electron of nitrogen. These guys are going to form a bond. These guys are going to form a bond. Okay, so that's a total of, if we count the number of electrons around nitrogen, how many do we have? If a line represents 2 electrons.
2.
So we have 8 around nitrogen.
We have 8 around nitrogen. How many do we have around each of the hydrogens?
2.
2.
2.
Good job. Okay, so they've met their octet, right? Meaning that now they're stable. They're like a noble gas. Okay, so every element wants to meet its octet if it can meet its octet. Occasionally, we're going to run into atoms that you're not going to be able to meet your octet. So if you have, let's say, NO, how many valence electrons does nitrogen have?
5.
It has 5, right? So 1, 2, 3, 4, 5. How many does oxygen have?
6.
It has 6. That's 1, 2, 3, 4, 5, 6. Now, in this case, there's a total of, if we add all of the valence electrons, there's a total of 11 valence electrons. So oxygen has 6, nitrogen has 5. So that's 11. Now, I will pay I will pay anybody who can fix it so that nitrogen and oxygen can reach its octet $20.
What?
Why do you always trying to pay us? Why don't you just give us like extra credit?
Okay, I will give you extra credit. I will give you 20 points extra credit.
What was the question again?
I just give
That's
him
the
You
whole
guys
test.
can, what was that? If
What was
you
the
guys
question?
can make it so that
That's like a whole
nitrogen and
assignment.
oxygen can reach its octet.
You have to give us a minute though.
I will give you 10 minutes.
To reach what? I can hear you.
Octet. So find a way so that they both can reach their octet. You can't add any extra electrons. You only have 11 to work with. So that nitrogen and oxygen both reach their octet.
Is it like trick question? You can't.
Probably easy. It's probably easy.
It is a trick question. You can't. Because it's an odd number, you will never be able to reach.
Okay, I'll take those extra credit points. Could add it to the exam.
So anytime that you have an odd number, right, of total electrons, you're never going to be able to reach your octet. The best that you can do is you want the one that is the most electronegative to have its octet met, and the other one needs to get as close as it can to reaching 8 around it. In most cases, you're going to get 7. Some cases, you only get 3. So
So what would the full answer be for that? Like if it was written out and we had to do the one with that was most electronegative.
okay, I'm going to do it right now. I didn't mean to erase everything just by accident. So we have the nitrogen with our 5 around it. And we have our oxygen that has 6 around it. So if we share 4 electrons between nitrogen and oxygen, it forms what we call the double bond. Okay, that means a total of 4 electrons are being shared.
Being shared on.
Professor,
What was that?
I actually got it, but I wasn't confident enough to tell you.
Okay, so then you have 2, 4, 6, 8 around oxygen, and then you have 2, 4, 6, 7 around nitrogen. Okay, so that is the best that you can do under those circumstances. Okay. Okay, so
Dr. Henry, I lost you. I'm so sorry. I lost you at that last part where you counted. You said 2, 4, 6, 8 around oxygen.
Yep.
And 7 around nitrogen?
That's correct. Because, and if you count total, right, let's count them all together. We only have 11 to work with, just to make sure that we have 11. We have 2, 4, 6, 8, 10, 11. Okay, so that counts for all of our electrons. Okay, piece of cake so far? Yeah, no,
Am I
maybe?
the only one
Yes.
confused?
I'm confused. Can you go?
If it's only me, I'll wait for like lab hours or I'll go to tutoring.
No,
But
this is the perfect
I
time.
thought-
If you don't get it, stop me now, because I
Yeah,
guarantee you that.
I don't.
The
Okay,
two that are shared in the middle, there's 2 on the top line and 2 on the bottom line. So if they're shared, wouldn't that give nitrogen 6? How do you get 7?
there's 2, there's 1, 2 here. They're shared, but you count them as if they're only revolving around nitrogen, because nitrogen gets it some of the time, right? So then nitrogen will have all 4 of these at some point together. So it's kind of like having them now. So that's 2.
Dr. Henry,
4.
I think my screen had some fuzz on it and it looked like 2 electrons on the top of the end and I was going crazy. I see it now. There's
Okay.
2 on the bottom, 1 on the top, and then the 4 that are the 2 and 2 that are shared. Got it.
That's correct. So that's a total of 4 electrons. Okay. And so all together, so there's 4 in the
Yes,
middle,
I got it.
right? 1 up top. So that's a total of 5. And then 2 at the bottom. That's 7. Okay? This
Got
guy
it.
has 2, 4, 6, 8 around it. And remember, you want to reach your octet if you can. Oxygen is happy. Oxygen has a strong electronegativity. It wants to be happy before anybody else except for fluorine. Fluorine is greater in electronegativity than oxygen. So fluorine is going to be happy before anybody else, period. Okay? Are you guys there with me?
Yeah,
Cassidy, did you get it now? Or do you
I
still not
got
get
it.
it?
No,
Okay,
that made
good.
sense. Yeah. I think you just counted it fast at first.
Okay. Okay, so if you have an odd number of valence electrons, then you know that you're never going to meet your octet. So you got to be creative. Okay, and so that's the case of no, and then also NO2. Okay? So in the case of, you also have another case where you could have hypervalency, meaning that you could have more than 8 electrons around you. Like for instance, you have phosphorus here, that's 2, 4, 6, 8, 10, that's around phosphorus. Now, this is only gonna work for those elements that are in the 3rd period or greater, because they can use the d orbital. The other thing, it's only gonna work when they're paired up with certain elements. So like fluorine. Fluorine is a bully. Fluorine really doesn't want to share, so it's not going to share multiple electrons with people. It's only want to get 1 electron, and that's it. And so it'll share 1 electron with you, and that's it, no more. Because fluorine is such a bully. It keeps everything close to its vest. Shares that 1, and it only shares it because it absolutely must share it. Okay? So this guy is called hypervalency. And that again means you have more than 8 around you. And so you can see it happens here with sulfur too. Then we have what we call hypovalency. And that's basically when you have less than 8 around you. So beryllium does this, boron does this. And again, it often will happen with things like fluorine, because fluorine is so strong compared to these guys. So hypovalency and hypervalency. So those are your 3 exceptions, okay? And occasionally the oxygen molecule will do some crazy stuff too that we can't quite explain so well, but it's a little rare.
What did you say hypovalency was again?
When you have less than 8 electrons around you. So like if you look around beryllium, that's 2, 4, that's around beryllium.
So in that case, even though fluorine has 8 electrons around it, because beryllium only has 4, then it's hypo.
Yes, it's called hypo because beryllium has 4, right? The center atom has 4 around it. And then, but fluorine is always gonna get its own. So that one's almost a guarantee. Fluorine is always gonna make sure it has 8 around it. You know, if he's bonding with somebody, he's gonna get his. Fluorine is like the biggest bully. So he kind of bends everybody to his will. He gets his 8, and he don't care about you. He's like that masculine man. The wife has to do everything. She has to wash the car. She has to take care of the kids. She has to do everything. Work 5 jobs, you know? And he just takes. He just said, okay, give me my 1 electron and we're good to go.
I don't like fluorine already.
So, okay. Simple so far?
Yeah.
No,
Yeah.
maybe?
Yes.
Yeah, it seems simple, but like, how is that going to be asked on the exam?
That is the question, right? That's what the homework problems are for.
Because I feel like when you explain it, it makes sense. And then I see that and I'm like, the exam, I'm like, what?
Okay, so the last thing is called metallic bonds. Metallic bonds, they implement what they call delocalized electrons. So your metals, right, they want to get rid of that electron, either one or two, depending on where they're at. So what they're going to do is they're just going to put that electron like right next to it and then kind of walk away a little bit and pretend like it's not theirs, right? And so by it's doing that, then that metal, the main part of the metal or the atom, has that plus charge and the electron has the negative charge. So it kind of tricks itself saying, okay, the electron's right there next to me, right? So I'm still positive. I am like a noble gas, but that electron is just there. It's not really mine, you know, but we're interacting, you know, because of that plus and minus charge. You kind of get that?
Not really.
Like this, okay? So here's your metal, right? So what your metal does, it drops its electron next to it, right? And what it does, it basically looks like a sea of electrons because you have all these metals that have lost their electrons. Because remember, let's see, you got to remember these guys here, like your alkali metals. What do they need to do to be like a noble gas?
Alkaline.
Stabilize.
How do they stabilize? What do they do to stabilize?
Need to lose.
Lose an electron.
One electron.
They're going to lose a single electron, just one electron, okay? Because they're going to lose one electron, then they're like the noble gas. So what they do when it's just them, right? They just say, okay, I'm just going to put this electron next to me, throw it out and pretend like it's not mine, right? And so then I'm positive, right? And so then I'm like a noble gas, you know? So it's kind of like lying to itself, okay? And that's what it does. Positive, negative, positive, negative, positive, negative.
And so
Because
that's
it just throws that electron on the ground and says, okay, you know, I'm good now, right? Do you understand?
so that's for a metallic bond.
Yes. So
It'll
metals
lose
are able to sit there and form alloys by doing this, right? So, you know, you'll have, let's say, for instance, 18 karat gold. 18 karat gold is composed of gold, silver, and copper, okay? Rose gold is composed of gold, silver, and manganese, okay? So they're bonded together, right? They're interacting together. They're one solid unit. They're not falling apart or anything like that. And the reason why is because they do exactly this. So you're able to sit there and have alloys. Alloys are mixtures of metals together because they form metallic bonds. And so they just kind of fake it, you know? Okay.
Yeah, they're not real compounds, right?
They're not truly considered compounds. They're just called alloys.
Are figure A and figure B the same?
Yes. So this is an example of a metal that is plus one. This is a metal that is plus two. So in this case, it would have two electrons that it just kind of spreads out.
Oh, okay.
You said
Okay.
the alloys are mixtures of metals that work to get rid of that electron.
Well, no, they don't work to get rid of the electron. They just do exactly the same thing. They take that one electron, like if it's a couple of metals that are plus one charge, that want to be plus one charge, they'll just drop one electron. If it's a plus two charge, they'll drop two electrons. If it's a plus three charge, they'll drop three electrons, right? So it just depends on how many electrons that they're doing. But all it is you could have mixtures of metals that are doing exactly the same thing. So like, you know how you guys have 18 karat gold. Is 18 karat gold 100% gold?
Nope.
Nope. It's a mixture between gold, silver, and copper. Well, what they do is just mix those three together, and then what they're doing is just dropping their electrons. So like silver is a +1 typically, so it'll drop 1 electron. Gold is typically a +2, so it'll drop 2 electrons. And so they'll be making that type of interaction between that molecule. So that it's just dropping those electrons right next to it, so that it pretends like, okay, I'm positive, the electron is a negative charge. Kind of like, you know how I talked about sodium chloride. Sodium is plus, chloride is minus, right? So the chloride molecules are going to surround that sodium. So that's the same thing that's going to be happening here with these electrons, right? Although the electrons isn't as big as an atom, but it's going to kind of act kind of like it's an atom, even though it's not. Do you understand? So in that case, the electrons are delocalized. They're still sort of attached, but they've kind of been separated because that atom, this is being the atom, the bulk of the atom, is dropping that 1 electron so it can pretend like it's positive. Are you with me now?
Yeah, I think so.
Okay.
No, I still didn't understand it, Professor.
Okay.
I lost you at the beginning and I tried to catch on, but I still don't understand what.
Okay. So we have sodium, right? We have sodium metal. Why does sodium metal form an ion? Why does it want to lose an electron? Are you there?
Yeah, I'm here.
Why does it want to lose
stable?
a single electron? To become stable, right? So it will give up its single electron, right? So that it can be stable. So then it becomes plus, right? And then normally it gives it up to something like fluorine or chlorine. So then chlorine wants it, right? Because chlorine wants to be stable too, and it becomes a minus.
Okay.
Okay. So what happens when you put a plus and a minus together?
They create a bond, an attraction.
They attract. They form an ionic bond. Okay.
Right.
So in this case, you have, let's say this is sodium, right? So in this case, we're having sodium saying, you know what? I'm going to pretend like I gave my electron away. And it just tosses an electron next to it. Right? Like a piece of trash. It just tossed it. Right? So then sodium is now positive. And that electron has what type of charge associated with it?
Negative.
Negative. So then it pretends like, just like this is an atom between sodium and fluorine, they interact because it's positive and negative. Sodium is trying to pretend exactly the same thing with its own electron. It's saying, oh, I'm positive and my electron is negative. Even though it's not really an atom. The electron is not an atom. Do you get that?
Okay, I get that.
Okay, so now that's positive and negative that is interacting. And so what happens is that we can start throwing in other metals in here. So instead of just having sodium here, I can also throw in magnesium, right? Magnesium is a 2+, and it'll do the same thing. And so they'll be interacting with each other, or I should say, they'll be interacting with their electrons, but they'll be in the same mixture together. Do you understand?
Yes.
Give it up to the other element that's in the bond with it.
But they're not really bonding. Like sodium is going to be positive, and magnesium is going to be positive.
Yeah.
Right? So they're just going to be pretending that these electrons are really negative charges, right? So these guys are never really interacting with each other. They're just kind of interacting with the electron.
Okay.
So we call it a metallic bond, but it's not like a real bond, you know? It's just delocalizing electrons, right? Where this guy is an ionic bond because you have a positively charged atom and you have a negatively charged atom that are interacting together. Okay. This guy, these guys are faking it till they make it, right? So these guys, magnesium and sodium, are not interacting together. They're just playing around with the electrons. Okay?
Okay, thank you for explaining that. I understand now.
Okay, so these are some examples of the most commonly known alloys. So like brass. Brass is just copper and zinc. Bronze, copper and tin. Carbon steel is 99% iron and carbon. Pewter, 91% tin, 7.5% antimony, sorry, and 1.5% copper. Okay?
So like for carbon steel, is the iron giving up its electron to the carbon?
So in that case, because remember, carbon kind of can play that plus and minus type of role, right? So in that case, carbon would be like giving up 4 electrons and throwing them down next to it. And iron would be giving up 2 typically, or 4, depending on which iron it is. So yeah. Okay, questions? Okay, so that's chapter 12. You guys got it? So the big take-home message is learning to draw structures and knowing the difference between the 3 types of bonds. Right? What bonds have we talked about? Or actually, technically 4, but
Non-polar, polar, ionic, and metallic.
So we have covalently polar or covalent polar bonds. We have covalent nonpolar bonds. We have ionic bonds, and we have metallic bonds. And which one is sharing?
Non-polar. Polar.
Not
non-polar.
Non-polar. I have it right the first time.
okay. So non-polar is sharing. Okay. Then polar is that sharing? Is it sharing evenly or unevenly?
Unevenly. There's a difference in the electronegativity.
That's right. And ionic, is ionic sharing or is it something else?
Something else.
Ionic is giving.
That's right. Ionic is give and take. Somebody's giving, somebody's taking. Okay? Are you guys good?
What about metallic? Those are give and take?
It's not really give and take. It's drop, you know, delocalize.
Drop?
Drop. Yeah, because you're dropping electrons. You're not really giving or taking, you're just dropping them. You're like, oh, okay, I dropped an electron.
Professor Sir, if we ever have to define a metallic bond, we can just put it's the dropping of electrons, otherwise known as delocalizing.
That's right.
Okay.
Okay, let's see. 13.
How much more tests are we going to have, Dr. Henry?
You're going to have about 3 more tests. Well, the next one is coming up pretty fast because we're almost done with with the material I wanted to cover. So, okay, let's see.
We're going in chapter 13 now.
Yep, chapter 13. And a little bit of 21.
21.
Okay, so we've talked about Lewis dot structures or Lewis dot diagram. So the way that you always want to do it, you want to count the total number of valence electrons. And then you want to try to figure out who's going to be your center atom. So the one that is always the least electronegative is typically going to be the one that you're going to put in the middle. And the way you can justify this is, how many of you guys have siblings?
What
What was that?
How many of you guys have siblings?
Me.
Me.
Yeah.
Okay, how many siblings do you guys have?
2.
3.
2, 4.
Five.
So
13.
how did you guys decide who sat in the middle when you guys went somewhere?
The smallest.
The youngest.
Youngest.
The youngest or the weakest, right?
Me.
She's like me. Yeah.
That's a smaller one.
The smallest or the weakest, right? Which are kind of usually comparable, right? Because if you were small and strong, you would probably out wrestle your sibling so that you would get on the outside. You would get pushed in the middle, right?
Yeah.
So the one that's the least electronegative, which means that they're a little weaker than the other guys, they're going to be pushed in the middle, right?
Yeah.
So your center atom is always going to be the one that has the least electronegativity, okay? In most cases, except we know that hydrogen can never be in the middle. Hydrogen always has to be on the outside. Also, fluorine is strong. It never wants to be in the middle. In most cases, it's going to be on the outside unless it's bonding with itself.
You said fluorine?
Fluorine, yes, the bully. He's never going to be in the middle, right?
Carbon's always in the middle.
Carbon likes to be in the middle because carbon's a whore. Okay? Okay, so let's start with ammonia. We kind of did this earlier. So how many valence electrons does nitrogen have?
5.
So it has 5 valence electrons. So let's just write it out. 5. How many does each of the hydrogens have?
1.
1.
You say 1.
Okay. So we have a total of 5 plus 1 plus 1, and that's a total of 8. So we have 8 electrons to work with. Who's going to be in the middle?
Nitrogen.
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 Okay. So let's start with putting nitrogen's electrons around it. Okay. And then we can start putting our hydrogens around. So this guy forms a bond, this guy forms a bond, and this guy forms a bond. Now count total electrons around nitrogen.
8.
Okay. Total electrons around your hydrogen.
Dr. Henry, you can also have them like the nitrogen, you know, you have the 2 electrons on the side.
Yep.
You can have them on top too, right?
Yep, I could have put it on top. Yep.
Okay. That's how I have them.
Okay, so that's your Lewis dot structure.
Dr. Henry,
Mm-hmm.
is it possible to put the hydrogen beside the nitrogen on the left side?
So you're asking if I could do this?
Yes, that way. Then
Yes, you could do it this way.
on top. I mean down. Okay.
Yep, or you could put it on top. That's
Okay.
fine.
All right.
So the
Because-
hydrogens have 2.
What was that?
The hydrogens have 2. I mean 1 or 2. Or do you
What
not
do you-
count this?
What do you mean by it has one or two? What are you saying?
Like when you form, like combine them, or not combine them, but like pair them, the electrons.
Yeah, so they're sharing, these are sharing 2 electrons. Each line represents 2 electrons. So it's been shared with the hydrogen and the nitrogen. Right? So that's how we get 8, because that's 2, 4, 6, 8. So nitrogen in this case is offering 1, hydrogen is offering 1. And so they're sharing. But you don't have to sit there and just give 1. Sometimes you may need to give 2, or you may need to give 4. So, but you're still going to be sharing because electrons are mobile, right? So you have the ability to move them around, okay? Does that answer your question?
Yeah.
Okay. Okay, so let's say we have something like this. Okay, so what is that guy gonna look like?
Carbon in the middle.
Okay, how many valence electrons does carbon have?
8.
4.
6. 4.
4.
So it has 4 is the correct answer.
4. Wow.
It has 4 valence electrons. And then each of the hydrogen have how many?
1.
1.
Okay. So that's a total of 8 valence electrons that we're working with. So this should be pretty easy, right?
Yeah. You'll just put an H on each.
Yep.
So this is the Lewis diagram, and then as far as testing goes, it would probably give us like those elements and then draw the Lewis diagram, correct?
Yep. I would give you the chemical formula and I would say draw the Lewis diagram. Or I would give you a chemical name and then I'd say draw the Lewis diagram.
Are you gonna give us like 4 different chemicals in it?
Oh yeah,
I mean,
don't worry. I'll make it. You're worried that I'll make it too easy. I won't make it easy.
No, I'm not worried about that.
Okay, so let's do something a little more challenging because, you know, we want to give you some experience, right? So what if I have something like this?
Would you write the carbons next to each other?
Okay.
Yeah.
And each carbon has how many valence electrons?
4.
Or does a hydrogen like go in the middle of the, no.
So we have a total of 12 electrons that we're working with. So let's go ahead and put our R's around our.
I think that's wrong. Is it wrong?
What was that?
Is that wrong right there? Or?
Oh, we're not finished. Remember, electrons are movable. They don't have to stay where they're at. We can move them around.
I was gonna say, can you put a hydrogen in between the 2 carbons?
Can you put a hydrogen between the 2 carbons?
I don't think so, because it only has 1.
There's always
Right. It always has to be at the end. It can never be in the middle. So no, you cannot do that. That is a big taboo. Okay, so we have what, 4 hydrogens to work with?
Yeah.
Okay, so I have 1 here, 1 here, and it's providing 1 electron, 1 electron. I have 1 here, and I have 1 here. Okay. I know I look like I'm drunk. Let me fix that. I'll just put it here. Okay, so does carbon have 8 around it?
No.
Okay, so, but what if I put these both in here and I form what we call a double bond?
Oh, yeah.
Right then? Okay, so then that's 2, 4, 6, 8 around this carbon. Then we have 2, 4, 6, 8 around this carbon. So we're good?
Yep.
Piece of cake?
Yes.
Dr. Henry.
Yep.
Will it be a taboo if I have 3 hydrogen to 1 carbon?
Yes.
It will be a taboo, right? Or it's right?
No, you could have 3. Let's say you have this chemical compound. So how would we do that?
So you'll add them.
I'm going to have 2 carbons. Oh,
I would add,
one there and one on the other.
okay. Okay, so now does carbon have 8 around it? 2,
Yeah.
4, 6, 8. 2, 4, 6, 8. It has 3 around this carbon, 3 hydrogens around that carbon, 3 hydrogens around that carbon. Piece of cake?
Yep.
Yeah.
Okay. Okay. Oh. Okay. So, do you guys mind if we tap out a little bit early today?
Yeah.
You do mind?
Not at all.
No, no.
Okay.
No, we don't mind at all.
Okay, but before we tap